The sixth-generation fighter jet from the United States will soon be unveiled, much to the excitement of the entire world. The most cutting-edge technologies ever invented have gone into the design of this next-generation airplane. With its unmatched features, the fighter seeks to dominate the air, re-establishing U.S. leadership in technological innovation and serving as a model for other countries' sixth-generation fighters. What powers does this new warrior possess? Is any other country creating its own sixth-generation fighters, as the U.S. does? Come discover the capabilities of the sixth-generation fighter, which poses a danger to the world's air domination. The concept of the sixth-generation fighter jet represents a new era of aerial warfare with advanced capabilities and cutting-edge technology. These next-generation aircraft are expected to redefine air superiority with enhanced air-to-air combat performance and the ability to penetrate denied airspaces. Building on the success of fifth-generation platforms, sixth-generation fighters are designed to adapt to evolving trends in aerial warfare, moving away from traditional dogfighting to long-range engagements using beyond visual range air-to-air missiles. In recent years, many countries have announced plans to develop their sixth-generation aircraft program, showing a global push toward advancing military aviation capabilities. The United States Air Force is a key player, actively working on the next-generation air dominance, NGAD stealth fighter program. Just after the United States unveiled its stealth fighter, the F-22 Raptor, classified information concerning the production of this fighter was illegally attained by a Chinese man, Su Bin. Then, in 2017, China introduced the Chengdu J-20 Mighty Dragon, their first stealth fighter, breaking America's hold on stealth technology. But the United States is never stagnant and is always working on new projects. Since 2013, which is prior to when China even revealed its first stealth fighter, the U.S. has been working on another project that would dominate the skies. In 2013, DARPA Director Arati Prabhakar announced that the U.S. had started studying an air dominance initiative. This made aviation enthusiasts worldwide very excited, as the new aircraft was expected to feature the most powerful engines, advanced sensors, integrated artificial intelligence, and a swarm of drone wingmen. By 2016, the U.S. Air Force joined DARPA's research, launching the Air Superiority 2030 plan. The Next Generation Air Dominance program is a futuristic project by the United States Air Force that aims to develop a new fleet of extremely advanced aircraft. The core of this project is the creation of a manned fighter jet known as the Penetrating Counter-Air (PCA) platform, designed to break through the most heavily defended airspaces and take on the toughest enemy threats. What makes the NGAD program even more exciting is the support these manned jets will receive from unmanned combat aircraft, referred to as loyal wingman platforms. These loyal wingmen will fly alongside the PCA, forming a variety of roles such as surveillance, electronic warfare, and direct combat, all while being controlled by the human pilot in the PCA. This combination of manned and unmanned systems will create a powerful and versatile force capable of adapting to a wide range of combat situations. The NGAD program is not just about building a better fighter jet. It's about revolutionizing air combat by integrating advanced technologies like artificial intelligence, advanced sensors, and new propulsion system. The NGAD aircraft will be able to operate more effectively and efficiently in the highly contested environments of the future. These innovations will provide the United States with unmatched air superiority, ensuring the ability to dominate the skies for decades to come. Moreover, the development process of NGAD emphasizes flexibility and rapid upgrades. Unlike previous generations of aircraft that had long development cycles and limited upgrade path, NGAD is designed to incorporate new technologies quickly as they become available. This approach ensures that the NGAD aircraft will remain at the advanced edge of military aviation technology, capable of countering evolving threats from adversaries. This project came into existence when the Defense Advanced Research Projects Agency, DARPA, was looking into ideas for air superiority systems for the U.S. Air Force and Navy in the 2030s. After finishing their Air Dominance Initiative study in March 2014, DARPA's results led the Department of Defense to start the Aerospace Innovation Initiative in 2015. This aimed to make prototype X-planes to show off future fighter plane technology. This program has changed how the Air Force usually acquires new planes by separating the tasks of designing, building, and maintaining the aircraft. They have allocated $9 billion to accomplish this by 2025. The plan includes holding more competitions and frequently testing the designs to ensure they work well. Although NGAD started with the idea of creating one type of plane, they are now planning to develop a group of different systems. At the core of this group is a manned fighter plane supported by drones and computer systems to enhance its performance. The goal is to create a system that performs well in the Indo-Pacific region, where current Air Force planes lack sufficient range and power. They might even develop two versions, one for the Indo-Pacific and another for closer battle areas like Europe. When the American sixth-generation fighter was just entering the concept stage, DARPA considered combining the expertise of specialists from the U.S. Air Force and Navy. However, it was soon recommended that these branches develop their fighters independently. Rumor has it that DARPA aimed to foster friendly competition between the services, hoping to get two excellent new generation fighters instead of one. Consequently, the Air Force focused on developing the NGAD, while the Navy embarked on its own FX fighter program. Despite various hypersonic and missile programs, stealth remains crucial for the future success of the U.S. Air Force. Making the sixth generation even stealthier might be challenging, given the near invisibility of the Raptor on enemy radars and the even more advanced stealth of the F-35 Lightning II. The F-22 boasts some of the most impressive stealth features, with a radar cross-section of 0.01 square meters, appearing like a small marble on enemy radar. However, its high cost of $350 million is a drawback. Therefore, NGAD specialists aim to equip the sixth generation with advanced technology while managing costs to avoid burdening tax. From fiscal years 2024 to 2027, the U.S. Air Force's estimated additional cost for the NGAD program will exceed $1.77 billion. Each futuristic fighter is expected to cost several hundred million, according to Secretary of the Air Force Frank Kendall. For now, let's set aside the financial concerns and look forward to the potential future characteristics of this advanced aircraft. The new fighter plane is expected to feature advanced engines that would be ready by 2025. Initially, they aimed to produce these new fighters quickly, similar to the process used in the 1950s, but they have now adopted a more traditional approach. The plan is to start using these new fighters in the 2030s, once they have enough of them. Some new technologies are being tested on existing planes like the F-22. Modern fighter engines perform optimally at a specific point in the flight envelope. To enhance efficiency at any speed and altitude, sixth-generation fighters may incorporate a variable cycle engine. This design promises better range, faster acceleration, and improved subsonic cruise efficiency. The engines will function as turbojets at supersonic speeds and as high-bypass turbofans at lower speed. Teams from General Electric with their XA100 engine and Pratt & Whitney with their XA101 are responsible for this capability. Working under the U.S. Air Force's Adaptive Engine Transition Program, they aim to integrate these engines not only into NGAD fighters, but also into the existing F-35 fleet. For instance, the Raptor is renowned for its supercruise capability, a core requirement of the Advanced Tactical Fighter program that led to its development. However, supercruise consumes a lot of fuel, so it is often limited to short tactical bursts during missions. If supercruise could be sustained for longer periods without excessive fuel consumption, it would greatly reduce travel time to and from mission areas. This presents a significant challenge for the team developing NGAD. The design of the new fighter will likely deviate from traditional norms, featuring a highly streamlined shape with an elongated mixed fuselage and wings without traditional horizontal and vertical stabilizer. This tailless configuration will prioritize low observability across a broad radio frequency range to enhance survivability while also improving aerodynamic efficiency. Fuselage materials will likely include advanced stealth coatings to conceal the aircraft from infrared detection and minimize heat emission. Combined with advanced thermal management systems, engineers must ensure that these stealth coatings remain intact and do not require extensive maintenance after each flight, even at high speeds. Another crucial consideration for the NGAD team will be the operating altitude of their next-generation fighter. The F-22, for instance, can fly at over 60,000 feet, nearing the point where pilots would need full pressure suits. Missiles launched from such heights can travel much farther than those fired from 20,000 feet below. Given the threat environment NGAD will face, which includes space and spectrum warfare, it becomes clear that the higher the altitude, the more versatile the aircraft. Higher altitudes also provide a significant line-of-sight advantage for the fighter's sensors and communication systems. At 40,000 feet, the line of sight is about 245 miles, but at 60,000 feet, it exceeds 300 miles. This extended range is a strategic asset, especially when navigating through dense enemy air defense network. Operating at such heights not only enhances missile performance, but also maximizes the aircraft's overall situational awareness and effectiveness in combat scenarios. Like every other advanced air fighter, the NGAD fighters need constant data exchange with collaborative combat aircraft and other U.S. Air Force and Navy planes. Acting as both a quarterback and a heavy hitter, the NGAD's communication range is vital. Every extra mile of connectivity enhances the fighter's survivability and expands its operational area without relying on beyond line-of-sight repeaters like satellite. Now to one of the most important parts, armament. The NGAD might be equipped with more than just the standard missiles used by the F-22 and F-35. It will also feature the cutting-edge A-26A Joint Advanced Tactical Missile that is currently being developed by Lockheed Martin. Additionally, it will have long-range engagement weapons. Raytheon is developing alongside its air-to-air missiles. For over a decade, senior Pentagon officials have praised air-breathing hypersonic systems as the weapons of the future, making them a likely addition to the NGAD's arsenal. And then, there are the weaponized lasers. The U.S. Air Force is already testing lasers with 100 to 150 kilowatts of focused power as part of Lockheed Martin's Laser Advancements for Next-Generation Compact Environments program and the Self-Protect High-Energy Laser Demonstrator. Joint effort by Northrop Grumman, Boeing, and Lockheed. Using these lasers to protect NGAD fighters from incoming enemy missiles by blinding or frying their homing systems is very possible. In June 2022, the U.S. Air Force determined that key technologies were ready to support the next phase of the program, called Engineering and Manufacturing Development. They had tested a full-scale prototype of the NGAD fighter plane in 2020 as part of the AII X-plane program and tested 3 different prototypes by 2023. They officially requested proposals in May 2023, with plans to select a company to collaborate with by 2024. Like many Western nations, Russia is also eager to develop a 6th-generation combat aircraft. Reports suggest that this new aircraft come from thorough research in collaboration with military experts. According to state media TASS, Russia is aiming to deploy a 6th-generation fighter jet by 2050. This development was revealed by Evgeny Fedosov, the scientific director of the State Research Institute of Aviation Systems and a respected member of the Russian Academy of Sciences. Fedosov detailed this initiative in a TASS column, highlighting the ongoing discussions and research around the 6th-generation aircraft concept. He mentioned that the process involves extensive consultation with military specialists to meet future combat needs. According to him, he revealed that currently they are thinking about the concept of a 6th-generation aircraft, conducting research, and exchanging views with military specialists. However, he went ahead to warn about the complexity of designing such advanced aircraft, calling it a potentially vicious practice. He noted that with each new generation, the size and weight of the aircraft tend to increase, raising costs. Fedosov also stated that the 6th-generation combat aviation group will include both manned and unmanned aircraft. He remarked that there is an opinion that the air group should be mixed and consist of drones and manned aircraft. Such a mixed fleet, in principle, can exist. He explained that drones could act as wingmen within a group, striking nearby targets, while human pilots would still be needed to understand the tactical situation after a strike. He did not specify whether the aircraft will be developed under a new program. Previously, Russia was working on the MiG-41 PAC-DP program to create a next-generation interceptor aircraft to succeed the MiG-31. Russia, however, has faced challenges in deploying its stealth fighter jet, the Su-57, in large numbers. Discussions about a sixth-generation fighter jet have also encountered obstacles. Some Russian planners have debated whether these fighters should be manned or unmanned. Evgeny Fedosov has also weighed in on this debate, emphasizing that while sixth-generation combat aircraft may incorporate advanced technologies, they will not entirely replace human pilots. Fedosov explains that they are trying not to replace a live pilot with a machine, but to create all the conditions for performing complex combat missions. He is, however, convinced that it is impossible to exclude a person from a combat operation. He acknowledged the impressive processing capabilities of neural networks, but noted their limitations in intuition and decision-making in critical situations. According to him, aircraft are becoming increasingly more intelligent, but this is the usual automation of the control process. Now, let's move on to China. Recently, a Chinese state newspaper unveiled an unprecedented tailless design rendering of its developing sixth-generation aircraft, showing a design that closely resembles several United States sixth-generation aircraft concepts. The exact design of the U.S. sixth-generation fighter hasn't been revealed to the public. However, the Chinese design looks very similar to the concepts shown by U.S. weapons makers a few years ago. The Chinese state newspaper Global Times refers to a video from the Aviation Industry Corporation of China where this design was shown. Paper describes the tailless, finless aircraft as having a blended wing body design, provides higher lift, longer range, and lower fuel consumption. However, its biggest advantage is its stealth capability. Vertical structures like tails and fins help with speed and maneuverability, but also increase radar visibility to enemy defenses. Protruding parts like fins, tails, and external weapons can be detected by enemy radar, as these shapes reflect electromagnetic signals. Sharp edges and tails are more noticeable to radar than a smooth aircraft like the B-2 bomber. This is why stealth fighters like the F-35 carry weapons internally, creating a smooth exterior to minimize radar detection. The Chinese paper mentions the engineering challenges, thrust vectoring for an aircraft without vertical tails. It notes that without vertical tails, the aircraft could lose maneuverability unless it uses other designs or technologies to compensate, such as thrust vectoring control-capable engines and split-brake rudders. Despite its stealth and aerodynamic design, the new Chinese aircraft seems to resemble U.S. designs from several years ago. This isn't surprising, as there are well-documented concerns about China's efforts to copy U.S. weapons specifications through cyber espionage. Not surprisingly, the technical plans and systems for China's sixth-generation technology, described by the Global Times in 2020, closely resemble those of the F-35. According to the Chinese newspaper, the new PLA Air Force sixth-generation aircraft will have an autonomous computerized system to gather, organize, and present various information sources to pilots. J-20 designer Yang Wei was quoted in the 2020 Global Times article, stating that a future fighter jet will need a longer combat range, longer endurance, stronger stealth, a larger load of air-to-air and air-to-surface weapons, and the ability to provide pilots with easy-to-understand battlefield information and prediction. This focus on providing pilots with easy-to-understand warzone intelligence is very similar to the F-35's sensor fusion. In an F-35, data from 360-degree cameras, long-range targeting, navigation, threat warnings, and other variables like speed, altitude, and angle of approach are compiled, analyzed, integrated, and displayed on a single screen for the pilot. The Chinese vision for its new generation fighter is very similar to that of the US. For instance, the paper explains that in an integrated system, the aircraft should form a network, generate real-time situational images, create multiple attack routes, and transmit target information across mission areas in real time. Artificial intelligence plays a significant role in early conceptual work and prototyping for U.S. sixth-generation stealth fighters. AI will likely incorporate more data types, including electronic warfare, space radar warning receivers, and unknown indicators into onboard system. Advanced algorithms can quickly analyze vast amounts of incoming information, compare it to a large database, and make near real-time decisions, computations, and analyses. This improves decision-making speed and clarity for pilots, reducing their cognitive burden. These are the fundamental goals of AI-driven programs, which is why they are emphasized for the new generation of Chinese stealth fighters. Technologies like conformal sensors woven into an aircraft fuselage, often called smart skins, are examples of new applications likely to be used in sixth-generation fighters. Other attributes cited in the Chinese report include new stealth configurations, advanced weapons like lasers, adaptive engines, and the ability to command drones. While much has been said about the stealthy exterior of China's fifth-generation aircraft looking like an F-35 copy, less is known about the internal technical specifics of advanced Chinese fighters. The real difference between what may or may not make a fifth- or sixth-generation aircraft superior could lie in AI's impact on computing, sensing, targeting, maneuvering, and various attack tactics. Thanks for watching. While you are still here, click on the link on your screen to check out another of our videos. See you there.